Hello and welcome to Identirati Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 207. And before we get started, a quick reminder to follow the live stream on LinkedIn or YouTube. The topic today is it's the first time ever. It's a new book club. And the first book we're going to talk about is called The Proof in the Code by Kevin Hartnett. Our guest today, as you can all see, is Rohit Khare. Welcome, Rohit.
Good morning.
Um, so, we're doing this at the last minute because we had a cancellation. Eleanor Merritt, who will be joining us later on, she's rescheduled for August 25th. So we pulled this together because you had sent me this book, I think, last week, and I've been reading it, and I was really interested in it. So I said, let's maybe do a conversation about lean.
Mm.
And my first question for you, Rohit, is will Leonardo Zamora's picture get added to the Computer History Museum's Wall of Fellows? Like, is he going up there for writing lean?
I I suspect that someone from this community will. Right. This isn't about anything about the History Museum or about awards, and it's not about an academic opinion of who should get what credit. There's a bunch of people I immediately looked for in the index of the book, so there are arcane and other considerations. So this is not so much a statement of that as a statement that what has become a new kind of community collaborative approach to mathematics is even more profound than just the technical ins and outs of this new approach in their language and how it relates back to our favorite topic, CEDAR, and computer security. And the fact that the way it's transformed math is going to be reflected and honored over time, whether it's for the creation of MathLib or CSLib or the language itself. Those are different forms, different professional organizations. But I realize that's hedging a bit, but I do think that's in that scale of impact. When we talks about the wall at Computer History Museum, it's something we often see in the identity community because it's where we host our internet identity workshop series for the last 20 some years, and you see these canons items of technology, the invention of the mouse, the invention of the graphical user interface, the invention of our programming languages, honoring GPUs and chips like that. As a result, I do think it belongs in that pantheon of ideas. The who's and when's. Hey, that's a science day for you.
You bring up an interesting point because, lean is a new way to do math. It's not just a new programming language or a new um, approach to formal reasoning, which is maybe more of a computer science
Mhm.
problem, but it's actually a new way to do math. Um, and from Demora's perspective, he sees mathematicians as early adopters,
Mhm.
but his goal wasn't really to invent a new way to do math. But did he? Do you think he really did? Is this a new way to do math?
So I'll take a bit of a discursive chat here for a second. My career in science, such as it really exists, like a lot of kids, begins with science fair, right? And going back like seventh grade, to STEM winder here, but give me a moment to let it build up. And I think my science teacher had heard about something about the four color theorem, which is this classic result a couple hundred years ago with this conjecture that if you have a map of the world or a map of any set of countries, you can color it with only four crayons, as it were, so that no two bordering countries share the same color, right? You want to make sure it's very distinct, that every country, has its own color, and any border you can see must be the two colors are different on that side of the border. And I kind of foolishly thought that meant it was an open conjecture as a kid. And I looked into it and I signed up for that, committed to my project title. And then I was like, what? What? It's proven? It wasn't the reason she misunderstood. It wasn't an open question. It was a very much closed question because in 1976, professors Pell and Hawken created the formal proof of something that had been laying open in the literature for 100 years. It was the first computer assisted proof because part of this was a few hundred pages of working through all the different kind of canonical configurations of how nodes on a graph could be arranged if they're in a plane and showing that yes, this is possible. And it created a lot of controversy because mathematicians were like, look, a proof is not an abstract mathematical thing in a game you play with symbols. A proof is a political process by which you get mathematicians to understand, agree, and believe in your approach to mathematics. And it's as much a social thing. Now, I don't want to get too high-minded about, sociology and the history of scientific revolutions and so on, but it was only, in fact, I think for a couple of years ago, that they used Lean to formally verify that computer-assisted proof that was so long and lengthy and that people took some decades to really be comfortable with really was, in fact, true. And that's why, the subtitle of this book that we're looking at here is, that how do you know if something is true? So as a result, my project actually tried to be like, well, fine, I guess I'll just blow up some diagrams of Monopoly and Trivial Pursuit and paint some game boards with 4 colors of paint. But it turned out to be a more interesting problem in time. But the idea that computer-assisted proofs were so radical, and I wrote to the professors, and they sent back a copy of the original paper and how thick it was, and the fact that their postmark at their math department was still 4 colors suffice. And that controversy, do people trust other mathematicians or do they trust computers, is finally getting resolved. And Lean's role is in some ways one of many languages. Isabel, Cook, well now Rock, um, Daphne, so many approaches to trying to help mathematicians write what they mean more and more precisely, and precisely enough that a computer can check it. But when you combine Lean with AI assistance and chat and internet scale collaboration technology, that's when you spark this revolution that's going on in a collaborative form of mathematics where we can build on each other's contributions. And as though the whole literature of math with all, the math lib could build on each other and do this. So let me stop there with a little monologue about saying why
Yeah,
it's so
that's
important.
that's sort of interesting because you're saying it's not only a new way to do math, it's a new way that the math community is going to organize itself for future generations.
Yeah. Um, if I may, can I tour a few open tabs? I'm going to keep this not too visual. I realize not everyone's listening in along here, but up here is like, the prop comedy, but we got the book here. We've got a few things, but if this is the first one is just the homepage for the book, which I believe you can just put up on the screen. So I believe I'm sharing it. And it says here, the key tagline here for Kevin Hartnett's book was, "How do you know if something is true?" I mean, that's just a kind of nutty concept of, trying to question truth to that level indeed. And here's like, just a UI to the main math lean playground. But they've added a new button over here in the corner next to examples and load and so on is, can I trust this proof? Um, and I will say that's kind of a fascinating concept as well. That how do you persuade each other of what's going on? And so, major banks have been doing stuff. Here's like Jane Street, which from a lot of hackers know because of their advocacy of formal methods, and they're like formal methods in the future of programming. They're beginning to believe this will happen. We're seeing a lot of new startups like Archway Labs is a really minor one, but I've met them through a few groups here. There's this don't trust blindly, trust and verify, right? We've got another grad school colleague of mine starting a company called Sigil Logic. AI for when good enough is not an option. For systems like cyber physical systems that must not fail, you need to use something like Lean or an equivalent. Harmonic.com is one of these very visible, highly funded companies. I think this one's with the ex-founders of Robinhood. They call it mathematical superintelligence, and their AI assistant's called Aristotle, where you can use AI to help you use Lean and learn Lean to prove what you want to do here. Axiom Labs, Axiom Math has also created, I think they're calling it, let me share this tab here. They were profiled. There was the first company launch that was profiled in the New York Times. I've never seen the word lean theorem in the Times except for twice this year. So Axiom system is called Axel, and they're calling it, what do they want to call it here? The starting point for all reasoning. I think this backlash that people need to combine math law approaches with just the language games to get to superintelligence has led to this explosion. Get two more, and I'll move on here. But like Math Inc., that was the subject of the second general interest news article this year. In part, it took a different tweak. It was interviewing the grad students in mathematics whose careers had been upended by the fact that their model called Gauss was able to take a problem in sphere packing and produce some proofs that kind of like, they'd been working on for years and like, in the application of a, maybe a few $100,000 worth of tokens kind of proved as kind of just a byproduct. On the other hand, I'll tell you, there's a lot of math projects that never get to $100,000 worth of grad student time to focus on either, right? So, Math.Inc. is another one. And most recently, I think there was a launch of Lean Straw from Mistral. There's one called Pramana Labs. You can stop the share now and get back to the video by saying Pramana Labs is backed by, I think, Vinod Khosla's venture fund, and they sponsored an event called the Verification Summit recently in June. And there we are with having the usual kinds of hype you see in Silicon Valley reserved for new chip designs, and they're having a big fancy flashy
Yeah.
launch with a few hundred people, and they handed out these boxes of the biography of Ramanujan, who will show up here in a second in our story.
Based on the swag, it looks well funded.
Mhm. Yeah, they attempted their Hello World was saying we think we can formalize things like tax codes. Now, famously, there is a formal version of the French tax code, but I trust the French. That's the kind of system where they ask, yes, but does it work in theory? In fact, today is Bastille Day. Shout out to the French. They're off to the quarterfinals of the World Cup. Here's that FIFA trophy. The kids have been building that in anticipation here, day by day. But France Morocco going on later today. That's why my Olympic shirt on.
All of its Lego glory. I'm sure that's more sought after than the actual prize.
Hardly, but we shall see. Today should be a fun day. And of course, I always remember Bastille Day because it's my mom's birthday. So happy birthday, Mom. But we were finishing this tour and sharing the screens here by saying, my goodness, suddenly we're at a moment, right? We have a sense at which, yes, we're pouring an immense amount of industry effort into large language models and helping assist people by moving words around. But we need to combine that with what's being called neurosymbolic approaches, right? Where we can both also leverage the fact that computers are, by the way, pretty good at math. And I think that this small group is worth attention to. So, we've been here in San Francisco at a new group called, and it's now got a domain name of its own, sflean.group. So sflean.group, we'll put in the links here after the chat. It's follows the New York City Lean meetup. But it has that amazing feel of started out earlier in the year with a few people. Now it's a few dozen. Now it's growing on Monday nights. Just people showing up to show off what they can do with the language. We'll come back to that a little later on. So end of that little rant. But,
Yeah.
pay
Let's
attention.
pin it back to the book a little bit.
Yeah.
The book is
For that matter, you point out his author is now in this business.
right. Kevin Hartnett works for Cursor as a marketing or product. I forget what area it's. I think it's in marketing, but yeah, and it's interesting because there's a couple of heroes in this book. Demora, I guess, is the main protagonist because he's as the author of the first three versions of Lean, and then he collaborates on the fourth version. But as sort of like the person whose maniacal vision, pushes forward from research to like reality. But who do you think? There's a number of other characters in this book and in this community, but I'm curious who you think is positioned as sort of the most important, like secondary character. And I'll give you a couple of options. Buzzard,
Yeah.
the weird mathematician from London with floral pants, who decides that this is exactly what he's looking for as a mathematician.
You flip right over to him.
Abagad, who I believe is one of the main, an early adopter who starts to collect, MathLib. And then, or Carnero. Is Carnero the one who does MathLib? Maybe Carnero does
There's a
MathLib.
large collaboration there. Yeah, Carnero gets a credit of God as well.
Yeah, maybe Carnero does MathLib and Abagad is a computer scientist. But I'm curious what you think about this sort of array of characters that's presented in the book, and if any of them like sort of really spoke to you.
Well, I mean, Buzzard is the one I jumped up at just because it's interesting that one of his challenges about, okay, fine, let's do this Jacobian theorem. It's this, 150 plus year old thing where there's a couple of algebra textbooks, but to really understand and prove it and teach a computer how to do it, it's kind of a challenge. And so some of the folks that are local SF Lean group have actually taken up the challenge of trying to translate, even old math can be revisited with this stuff. So Buzzard, I think, is a great provocateur. I think the quote here is that, this is what real maths look like. It's a million miles from anything that's ever been formalized before. And that's a word I wanted to stop and rewind for our audience a little bit on, which is that formalization is different than simply proving something or simply writing down a theorem in a traditional paper and getting it published in a journal, right? It's kind of a bit of like that tediousness of saying, can I really say what your axioms are? So, I don't want to turn this into any kind of a tutorial. That might be a good time for another time in another place. But for one word that, if the audience takes a few things out of this is that keep an eye out for this formalization problem. Because when you look at business process and governance, kind of our favorite topics, we get back to the hard work is in turning things into rules and understanding what you actually want of the system, and so do what I meant, maybe you haven't thought about how all the different parts of the tax code interact and maybe contradict each other or create loopholes. And until you formalize it, you can't say, aha, there's the contradiction. So formalization is as much a matter of like, as we say, well, you got to see to your path intuition on what's morally a right thing to do or good or bad. But you can have somewhere between the 10 commandments and your full on set of laws and regulations the police department operates under is a process that's analogous to formalization of rules and regulations and laws. And that's probably the biggest contribution is spreading the word. So I don't know it's necessarily a story about a couple of great people. But yes, in this narrative, he makes it quite interesting. And a couple of these characters that stuck with you too, I'm glad that, the details work and he's such a great writer at this. I was going to I would say that the one other name that was not on your list there was the creation of the natural number game. So I'll pause there for a second and say if you recall the role
Yeah.
that in the book.
Yes, and they still talk about that as being sort of a test of somebody who's basically either attended a workshop or I guess played that game or done that exercise online as an initiation. And that actually brings me to a good point, is because I feel like not only did they do this game, which I guess was developed to teach undergraduates initially, but then they publish it on the website. But they also form a conference
Yeah.
called Lead for Mathematicians,
hmm
which was an educational initiative. It was like a 2-week workshop where they invited mathematicians from around the world, particularly mathematicians who were sort of leading, who they felt would help shape the industry for the next 2 decades. So
I
the
remember
lead,
they got freaked out that they got the equivalent of Nobel Prize winner in our fields methodist named Morel to show up at this. In fact, actually, an anniversary of that day too. They were saying the inaugural Lean for the Curious Mathematician started on July 13th, a few years back, and they tried to prove, what are primes, and that challenge of what are prime numbers, allowed them to organize this and get people back into it. But this game, so I was saying that the balance between learning some math and getting excited about the people and the drama and what are the business implications is the hardest thing in science communications. In fact, that's what I'll pivot back to in a second about why the natural number game is so important as a kind of lesson for us as computer types and software advocates for new technology. But Mike, did I cut you off in the middle of another thought?
well, I wanted to talk about tactically about, so lean is a great thing, but I feel like there are also some lessons here on the difference between commercialization and research.
hmm
And you, of course, showed all these startups because now lean is in a different phase. Um, but there was a time in 2013 when lean was very much in the research phase. Um, and it took a different approach. And I feel like that there are some lessons to be learned here for why research is important, and also what could we do better. So sometimes, like, what does the research community get right? Maybe in catalyzing a new technology like this that maybe is that we don't always see as as people in the middle of Silicon Valley who are very focused on product and commercialization and monetization.
Well, I think it's at its best. Technology evangelism is a term that's very much from the commercial Silicon Valley side of things, software marketing side to speak. But the structure of scientific revolutions, to use Kuhn's term, is also still a matter of persuasion and politics and marketing and positioning. And like open source, I think collaboration is often the winner here. And while again, I remember grabbing the book and really looking up in the index, I'm almost sad that I didn't see Cedar, right? Because we're like, hey, that's our thing. Is like, how can you prove things about whether a cloud security configuration really allows interns to access this bucket, or whether you can really be sure that in your company, all of your data is encrypted properly. And that's a huge application area. And actually, the people paying the paychecks for Leo DeMura's salary at Amazon, are arguably the funding of this amazing team at Amazon Science science and there's different colleagues involved there. I mean, they're also supporting the research of CS-lib, the computer science equivalent of this revolution with Barrett Clark at Stanford. Well, hey, they're really talking about the fact that these other languages I looked immediately, they weren't in the index, and yet there's huge pages of great stuff in there again. Great book. Is to say, I perceive from this book that Lean got one thing right that tech evangelists look for in software systems or in new standards from like OpenID or so on, which is that you need to put foremost how do you make the community around your ideas. That simply shipping a better mousetrap doesn't kill mice. You need people to buy it, to know what's out there in the market, to work together. And of course, the mousetrap's a terrible metaphor for creating community. If I use a mousetrap or you use the other one, whatever, we don't care. But when my proofs get committed into a shared common library of other facts and axioms and make our mathematics library better, or we can now get into topology or do a new field, that's an amazing flywheel or network effect. And network effects are, I think, one of the lessons learned from why Lean succeeded to a degree and in a way that maybe not a head-to-head comparison of different languages and their mathematical approaches may or may not have opinions. And Lord knows, I'm not qualified to comment. But I will say that they are definitely taking a lead on what the great mathematician today, Terence Tao, another one of our Fields medalists, sees as a revolution in mathematical affairs. That's one point.
And I like the part where Hartnett talks about Demora sort of thinking about Amazon's product strategy, where you think of the press release first,
Mm-hmm.
and then you develop the product. And he has Demora sort of thinking about, in 2013, I didn't really know that mathematicians would be my early adopters, and he didn't know generative AI would even happen, like
Yeah,
7 years later.
yeah.
Um, and so I think it also says something, but then I started thinking about it. And I'm like, well, maybe Amazon's tactical approach is right, because does Microsoft actually see a return on that investment? They gave him bonuses. They gave him good write-ups every year. He was terrified he was going to get a bad review.
Mm.
Um, and he writes this really, really important piece of software. But does it justify the research, or does it justify Bezos's idea that that maybe this shouldn't be done because you can't even see how it's going to be a product when you start it?
Well, yeah, I was immediately reacting to the great man theory of a great person theory of history, right? So, whether Bezos had an opinion, I have no idea. But I will say there's a philosophical disconnect between, say, customer obsession and saying we will wait for the customer to tell us what they want us to go build next, and
Mhm.
technology obsession, which is, hey, this new thing is possible. I'm going to go build this rocket, and then we'll figure out who wants to ride on it. In this case of Bezos and a few other people, quite literally. Um, I do think the working backwards method helps out here, but I'll give you an example of what Leo himself holds up as why this has a return on investment for their backers, right? We're a long way from the days of AT&T Bell Labs and just doing basic science for its own sake. So he pointed out a real revolution in putting a new background on vibe coding earlier this year with a post on revealing or kind of announcing that they have created a formally verified version of zlib. Now, ZSTD compression, like basic data compression, seems like an algorithm you think most of these things will be worked out the kinks, right? Almost everything we touch on a file system is compressed or send a zip file or you're doing the equivalent of that. The libraries for it need to be high performance, so people are constantly updating them because they're down in the kernels to make sure we're compressing even virtual memory blocks. But how do we know each time we commit it that it's still actually able to decompress and recompress the data comes back out as exactly identical? But also that you don't have subtler bugs like it blowing up memory or it causing other processes to crash in the process, or maybe doing weird things with the files of certain lengths or bad patterns that just have never been compressed
Yeah.
before.
Or you put some input in it and it gives you root access.
Right. Well, there's classification of both implementation bugs, which are important, and specification bugs, and they've solved both of those. So because of this investment in the lean FRO and kind of what's the return on what's in it for someone like a hyperscale company like a cloud vendor, well, this whole teetering of world of cloud computing does reply on like, hey, does the kernel work, the hypervisor, all this investment making security, but also works on these low-level algorithms. So he's talking about creating a public commons of well-trusted components. And whether those are implementations of OpenSSL or of a standard compression library or the kernel hypervisor itself, or for that matter, a cloud identity and access management system. Cloud IAM systems are the thing. That absolutely powers everything else and every other assumption you make about security. And if they fall, there's just beyond catastrophic consequences. At that level of cyber physical systems, of healthcare systems, of core computer science systems, of core cryptographic algorithms, Web3, these are all areas where formal methods have traditionally been a go to tool. Regulators sometimes require them for public interest safety. But making this radically cheaper to do, making it radically more accessible through AI, and making it radically more applicable by embedding it in these easy to use tools and playgrounds. And so that people who are maybe using Cedar and Cedarling are benefiting from analysis toolkits and they don't have to learn about the existence of these new breakthroughs. That's, I think, a really big impact that we're having at this moment in time when compute is possible and this community has come together.
And Microsoft, one other thing that struck me about this story is that Lean is created by one guy until Sebastian Ulrich, I guess, gets hired as an intern.
Yep. Yeah.
When they're writing Lean 4,
Mm-hmm.
he's like the most qualified intern of all time.
Mm-hmm.
And it's basically written by one guy or two guys max. If you consider Lean 4 really the final product.
Mm-hmm.
But I'm always amazed how sometimes like really important software products or projects are written by a relatively few number of people.
I was just going back to confirm that. There's one line on Amazon, the index, AWS, two lines on Google, maybe 10 lines on Microsoft Research because of Ulrich's impact. But it's generally not a story of companies doing this stuff, right? We're in the moment right now where national security and foreign policy are being driven by our energy needs of AI and the needs, corporate interests of companies. But that's not where these breakthroughs happen. There's usually a couple individuals, and how do we see that being at the coalface of innovation, right? The science of progress studies. It's amazing to see, and it's fun to be around. Even if that's why I encourage people to read the book and at least get a flavor and be excited about new things happening. Then even if they're not going to be able to use it in their day-to-day work right away.
One of the subplots in the book I feel is reinforcement learning, and the combination of Lean and reinforcement learning. And so one of the applications I think that we're seeing for Lean is generative AI, and particularly how it's prone to giving you bad results, or you can't be trusted to do math or to check your math. I thought it was interesting how do you gamify math? And Lean provided a way to, like, we know if we have like a program play Go or play chess, that they did something and it wins. And Lean provided this way to like almost provide a reward system for doing it right.
Well, I've heard two senses, and I want to just peel them apart of at least two ways when she used gamification in there, and it applies to Lean. One is that a game creates a social construct, like this fun and play and cooperation, and that Lean gamified math and math lib in a way that lots of people can contribute. And now, as Terence Tao has pointed out, the future is not yet more superhuman efforts in mathematics, like stories of the lone genius of Andrew Wiles solving Fermat's last theorem, after many years in almost quasi seclusion, and then suddenly dropping on the world as breakthrough. Instead, he's seeing amazing progress being made by teams of mathematicians working like software developers do around the world, around the clock, with AI assistance. So there's a way in which it's gamified in that sense to be more convivial. There's a second sense which is gamified, which is that AI agents are particularly good, in my observations and opinions, they're just those, at playing games and winning games, right? From the earliest DeepMind experiments to learning to beat an Atari game to, AlphaGo, as you pointed out, and then later on AlphaZero, saying I can not just play Go, I can play any game and start from scratch by self-play, reinforcement learning, as you said. So the ability that Lean and its ilk bring to the table is that it's very easy to imagine a coding assistant agent getting better and transforming our economy right now, because what you produce has to either compile or interpret and run or not, and it may need to pass some test cases or not. And the agent, essentially an AI loop, can just keep beating its head against the wall, Ralph Wiggum style, till it figures it out because it has a feedback loop. Well, if you ask someone, write the perfect diet to help Rohit lose weight, that's a kind of lean I can't get solved, right? Because it involves changing human psychology and things that are hard to model and things that might take a few years to see whether that habit sticks or not. But making things into a game like simulated environment, that's a huge win. And that's why all this money is, I think, one theme behind a lot of investment in these startups is that formalization, auto formalization allows you to take a underspecified vibe coded problem and give it a kind of a rigorous enough test that instead of having to kind of shotgun style try out a bunch of random weights and tests and saying, hey, does this mortgage application process I've just vibe coded work for this set of 3,000 test mortgages? And say, no, I can prove it by generating the complete set and using this feedback loop. Again, some of the great results from AWS on verifying and deploying Cedar at scale is that you might have a toy implementation that's formally proven and absolutely correct, but the one they run at Rust at scale that's running at a global distribution of millions times per second might be a different implementation, but I can use the formalized model to both test the implementation is still behaving the way we wanted the formal version to work at scale. So gamification here comes back to saying both it's a game in terms of turning math into a game, but it's also a gamification that when you make it into a game, AI is particularly good at going off in a corner and then learning on its own to get better at playing those games, like finding these proofs.
Yeah, it's interesting about how you mentioned early on in that last comment about
Mm-hmm.
how it enabled collaboration between teams. Like one mathematician saying, "Okay, we
Mm-hmm.
see this big problem is four big parts, and those four big parts are each actually like 20 or 30 different littler parts."
It's
Like,
like when
because
you
we
go to the deli, take a lemma.
yeah, exactly. And so it is interesting how it fostered this ability to work together to chip away at a problem,
Mm-hmm.
and so I don't know if that's specific to the math community because I'm a little bit wary of taking the early adopter community, which is mathematicians, and saying, and it was really helpful for mathematicians, but will that necessarily apply to the other markets like Cedar? I'm not
Mm-hmm.
sure. Um, but it is interesting how it has fostered collaboration in a new way in the math community.
Well, I think it's going to borrow in a more fundamental way that the kinship of engineering disciplines, whether it's handbooks of bridge design manuals or reference tables for chemistry or so on, is that these collaborative intellectual works work because we make communications cheaper by having a standard model of particles or having a standard model of equations or of topology. More people can catch up with each other and understand each other's languages more effectively. So open source code has become so dominant because it's easy for another engineer to maybe pick up a piece of code and be able to maintain it, modify it, hack it, and grow with it in a way that you couldn't necessarily do it if you could only license a binary copy of the software in the old ways. This is kind of bringing that open source to mathematics. I think it's not just that, hey, mathematicians are an early target market, and it could have been auto mechanics or engine designers or orbit designers for rocket science. I think it's a very fundamental analogy that holds true, which is that by expressing your artifacts in a way that you and I can review, it becomes more like Wikipedia, it becomes more like GitHub, it becomes more like MathLib. Those are why I'm excited about this.
Yeah, I wanted to talk about open source. This type of collaboration, I think, was a good fit for open source development. I've noticed that systems that have a lot of connectors or plugins tend to get very
Platforms.
diverse. Like WordPress, for example,
Mm-hmm.
but also there's a number of like monitoring, like network monitoring tools where you need a lot of connectors, those types of ecosystems, database connectors. So I think this was a conducive problem to solve with open source. But I also feel like this effort is the poster child for some of the challenges of open source because the line finishes or the book finishes. Hartnett writes, something like, actually I wrote it down. He says that Demora, after, so Abogad and Demora are walking, in Seattle roughly 11 years after Lean was released. And Hartnett writes that for nearly the first time ever, Demora was filled with optimism about Lean's future.
Mm-hmm.
And I'm like, optimism? Like, Well, then I thought about it and I was like, okay, well, in July 2023, they get an FRO, which is like a 5-year commitment for funding.
Mm,
2028 isn't that far away. So we're already now a couple of years into that.
yeah.
And they have no long-term, nobody raising their hand, and saying, we're gonna back this thing. All of those startups
Mm,
have precious venture capital, which needs to be invested in buying market share and buying swag for Silicon Valley
mm,
developers. And they say that they're going to form a foundation,
mm,
but I still see some uncertainty. And by the way, I looked at Leo
mm,
Demora's LinkedIn
mm.
profile,
Yeah.
and it says he volunteers. He's in
Yeah.
the Amazon Automated Reasoning Group,
Yeah.
um, and he volunteers on Lean. Although
Yeah.
they just shipped a new release, I think, in July, and they have 40,000 commits, which is a lot of commits since
Well, I mean, the
2000.
commit volumes and sizes are different to compare to like software, but also AI, coding agents are changing that for software too. Let me step back and say this is an area of different conversation about the ins and outs of how consortia are founded, how multi-organization cooperation happens, how you fund and things in our modern corporate culture versus the old corporate R&D model, and so on. So volunteers at Lean FRO is kind of like saying someone's an advisory board member to the W3C or so on. Like there can be multi-dot organizations that have huge budgets, like an ICANN that runs a domain name system. They can be small. They can be in between, like OpenID Foundation. You've kind of worked with different people in our circles who have some combination of startup funding, salary funding from a large company, donations that keep an independent organization at it. And of course, the role of academia itself. It's more telling that Lean FRO at least exists, and it's not just the domain or the reputation of one university's particularly well-funded math department or the successful reputation of a coterie of one person professor and their students at a couple institutions. These are all new, innovative, and exciting ways to organize global efforts, but they're hardly unprecedented in their details. I think what's more relevant is to say I have no doubt that come 2029, Amazon will still be funding into it. What I'd like to say, I'd like less doubt about is that about another couple of dozen companies around the world should be also hiring and expanding and investing in this to the same degree that they have. Um, that's an aside on that front.
Yeah,
I think that the public good aspect of it still has a long way to go forward to play out. The fact that it is expensive currently, even with this revolution in tools, to take something like a compression library and say, here's a version of it that is both performant at scale, been reviewed for security bugs, and actually meets the spec in a way that you can really rely on to build other some reliable software systems around, is a huge win. But it's not really possible to say from scratch, hey, AI, create me a new, better compression algorithm, and by the way, be certain that it's perfect. No, you can't do that, right? It's based on the fact we've got decades of work in compression that was all in open source, with all the changes committed in a way that we can study and understand as part of an open source kernel. So for our folks in software using formalized approaches, you know, formalizing and proving the little hack I want to do to track my bucks in my library and which of my Lego kits are built and unbuilt, and is that little inventory app going to ever make a mistake or get the wrong price? Right? But for these things that are critical social infrastructure, we will find ways to find funding if it's not obvious. It's not necessarily DARPA or NSF or some company, but I share his optimism at the end of that book.
yeah. Maybe as somebody who runs an open source software vendor,
Yeah.
I see more warning signs here that a community as successful as Lean, where they write a book about it, still has uncertainty in it, to the point where I
Mm.
think Demora is perhaps worried. He's optimistic,
Mm.
but he's not like, I did it. It's like, I'm done. This thing is like, I think he's still like, I don't know what's going to happen, because maintaining software never ends. Now people actually want features.
Yeah.
And so it's actually hard to maintain this thing as it gets more adoption. And it's not clear, 100% clear how that's going to happen. Although I share your optimism and his optimism that in this case we'll find a way. But
Mm.
I also see it as a red flag for open source in general, that the poster child for success, for strength after strength, still the best they can do is optimism and not be like, yeah, we nailed it. We did it.
I mean, would you say that Linux has nailed it? I mean, I would love
Yeah.
to see a fly on the wall for a one-on-one between, say, Leo and Linus Torvalds. I mean, Linus gave a talk apparently at this Mumbai open source conference for
Mhm.
Linux's annual meeting, and talking about how his role has evolved over all these decades. To whether he's using Rust or using AI or really managing other people. He's not like kernel maintaining himself, but even someone like him, I think, would probably agree from his tone and other comments that you can only be optimistic. Even Linux isn't clear what its future is because there's so many stakeholders and so many things going on that you can't say with certainty, hey, this edifice will be around and operate with these processes, some years in the future. Or so just saying that I think that part of what gives me optimism is that he only has optimism. When you see the startup founders, the next wave of people who come out with like Jobsian levels of messianic drive and absolute, conviction that this is the only true way and there's billions of dollars at stake and start lobbying Congress, I guess I'll be more skeptical. But the kinds of folks who have the intellectual humility to say, I don't know for sure, are probably the ones that will still be there playing the distance over time.
Yeah. I
I know
wanted
we
to
did.
talk to end by talking about like lean in the real world. So we mentioned Cedar, obviously the connection
Mm,
that my connection to lean, let's say, is as
mm,
weak as that is as a advocate for Cedar,
mm,
which was used in the or for lean was used in the development. I think they originally used Daphne, and
mm.
then they I think formalized it in lean,
Those network effects at work for
which
again,
makes
hard.
sense
Yeah.
with Demora going to Amazon Automated Reasoning. It makes
Oh.
total
Well, look,
total
he went
sense.
from Microsoft research there, but so did the inventor of Daphne, right? The question is that the question is to get into the politics of the people or the comparative advantages of different approaches to interactive theorem proving. It probably does say something though that says even within the scale of a single company, you can have snowballing network effects that we're all better off if we have a whole run of projects run by dozens of different researchers that are all using the same formal language to formalize their statements, i.e., lean. And that standardization can snowball within a company even before it starts snowballing outside of a company or creating a flywheel effect, if you will. Um,
And it's still TBD how that will work out. You mentioned zlib, but
mm,
the other, also in the identity industry, cryptographic algorithms are really
yeah.
important to us.
Mm,
And knowing that they work is really hard. Actually, NIST
mm,
verifies
yeah.
FIPS,
Yeah.
I forget it,
The
FIPS 141.
Federal Information Processing Standards for
Yeah.
encryption. And those are decades of work. And these, we were going through this with post quantum cryptography right now. You've had a couple of good episodes on that, right? So, how do we
Yes,
ensure
exactly.
that
That was
post quantum?
exactly where I was going.
Yeah.
Is how do we verify these post quantum,
Mm,
and so I was excited to see Microsoft, one of the applications they saw, maybe they are getting an ROI on
mm.
this, because one of the applications that I saw was Microsoft basically formally verifying a cryptographic algorithm, and I have to admit I thought, hey, I'd like to use that algorithm.
Well, you want to verify the algorithms, the actual elliptic curve algorithms and the implementations are accurate, and then the protocols they build on them, because you keep seeing scams and saying the Web3 crypto space where, um, you know, whatever. There's reasons why even these smart contract protocols need some proofs as well too. So there's so many layers of the stack of software, and at each level of staff, we have to say, you know what, we have for generations been operating with satisficing, good enough software that seems to work often enough. But if you can actually really want to rebuild your civilization around things, it'd be nice for at least some of those load-bearing members to be quite sure of what they do. And if you're doing a hobbyist trading application for stocks, that's one thing. If you're Jane Street earlier, or a major hedge fund, trying to write a program trading bot, how do you really be sure it keeps respect to your value at risk models and uses your governance policies, and also, by the way, checks that there's not self-dealing of buying your brother-in-law's stock to pump it up and so forth, right? Those are, I think, the real frontier, because as we ascend up to vibe coding, and I'm starting to see for all colleagues and professionals treat even source code as just the way we would traditionally have treated object binary code. I don't know. I don't check in binaries. The compiler takes C and generates a .exe file. That's not my job to go code review .exe. Well, now they're like, I'm writing prompts, and it's not my job to code review the TypeScript it's generating. That would be a waste of my time. Well, as you keep ascending up this thing, it can get a little rickety, right? So, knowing that there's also a way to balance this race to get more vague and more vibes based, along with this more rigorous, more formal approach, is what we need in computer security generally, and we need that for identity protocols as well as the underlying crypto.
Right. I
Yeah.
think that's a good place to actually break. I think that's
Well,
let
I
me
did have one closing thought for our Doves moment here, if I may.
uh, yeah. So please,
Yeah. Well,
let's
just
give you last
it was
thoughts.
just to
Go
say
ahead.
that, yeah, my last thought on this is that the natural number game is one of the lessons I learned most out of this book. So I actually got more insight from my daughter. I actually wish she'd actually read the book in more detail and actually wanted to chip in. As not a mathematician, but she's actually off attending a science communications course at the moment, in summer internship thing. And the thing about convincing other people about a new way of doing things is the way to invite them into using your software or your standard or your concept of GovOps or an approach to a new authentication protocol. And the gamification that happened here is by saying, let's take a domain called natural numbers. How do integers work? What's a prime number? In fact, this group and meetup that got me excited about happening here in San Francisco began with a call to say, does some group of people want to get together and just work through the natural number game that they invented for that Lean for Curious Mathematicians event together? I'm not quite in that same little brain power league. I don't think I've done that. I still need to sit down and do the game. But I find amazing that she's taken that idea and sold that to people as an idea to people in genetics and other fields, because the idea of saying, welcome to this complicated new idea. We want to get you from zero to contributing with it. And it follows the kind of, in the old days, maybe it would have been a textbook, but now it's going to be a game like natural number game. It's going to be something participatory and something collaborative. That's some of the most essential kind of portable takeaway from watching this little ragtag group become a movement, and Kevin Hartnett's book on it. A natural number game as an evangelical tool and a developmental construct in a way that science happens.
Awesome. Yeah, I think also a good place to leave it.
Mhm.
That was our first book club. I'll just remind our audience that every episode has a wiki page.
Mhm.
Um, Red actually bought the real paper book, which
The
is
audiobook is amazingly effective too.
um, but we have episode notes.
Mhm.
Rohit, if you want to share some of those links to the startups, I'll add those to the episode wiki page. Um, and I put some links to Lean in Action. I put a link to the book up there, of course. So every episode is glue.co/IOH the episode number. This is episode 207. Quickly announce the next episode, especially since I've been a little remiss in scheduling. But our guest on Thursday will be Nicola Gallo, one of the foremost thinkers in sort of how authority gets delegated across in a distributed network. He's always he's really on the cutting edge. So glad to be hosting him. Um, Appropriate music for Stacy music for Nicola. Um, and with that, so Rohit, thank you so much for telling me about the book last week
Mhm.
and for being a last minute fill in for our book club.
Thank you to also everyone at the SF Lean group that told me about the book. So sflean.group if you're ever in the area on a Monday night and want to come nerd out about it. I tried to maybe make a fraction of those events, but welcome to that. And I hope you have a great day, and vive la France. Good luck on today's match for us, or either side you take. It's always going to be great soccer. So have fun time. Just hope to see you back here soon.
Okay. And one last logistical reminder, if you haven't done so, follow the live stream. That really helps us out. And we'll see you next time.